Okay, so we've also got we got the calculator. So, and we know that if we want to do simple math, it's pretty easy to do. Algebra, for example. There should be something up there for uploading assignments. Should be a link for uploading assignments. So we know that on a calculator, and let me bring the calculator back out. Where is it? Come on. Here. Okay, good. When we want to do simple calculations, 2 times 2 is equal to something like that, we get it very easily. It's fairly easy to do. We can do it longhand. But there are some mathematical calculations that are too complex for us to remember how to do. Raising something to a power isn't too tough, but other things might be. So Java provides something called a math class to do that. And you can think of the math class as being the equivalent of going to calculator and clicking scientific. Because now you see you got all these extra buttons here. Got all these extra buttons here, and I think power might not be there. Oh yeah, that's power right there. No, yeah, there it is. So what happened? Hate when that happens. Okay, so the math class is like the equivalent of clicking that view calculator or view scientific and gives you that additional information. So math has what we would call methods to allow you to do certain things. And we'll look at some of them in a moment. I'm sure it's just going to be math. Yeah. So if you do in NetBeans or wherever you're at, and you do math and hit the double sign, the dot, drop down a list of stuff that you can do. And if you look at it, you're going to see that there's going to be correspondence between all these things here and let's say what's on the calculator, right? Actually, the math class will probably have more. Quite a bit. We got pi in there. So you got quite a bit. So math is kind of like the scientific portion of the calculator in which it provides special buttons. The calculator has different buttons for doing these things. And the math class has what we call methods. The methods is the equivalent of one of these buttons. And so it helps you out. So that's essentially what the math class is. It's built into Java, and it helps you do some more complicated stuff. We could take this thing, copy it, and paste it, and I can do it right here. And we can go ahead and run this thing. And of course, it's going to want me to enter a value, 655. And then it gives us that part again. Then we get this 0.16, which I guess would be 2.5 to the power of -2. So that's going to be useful when you're looking for doing some more complicated variables. And here this thing says number literals. And you're going to see this a lot. We're going to see it with strings as well. A literal is essentially a constant typed in variable that's typed literally into the code. So it means you literally type it into the code. So, for example, in the old example, in the prior example, we had radius equals 20. And then I replaced it with the prompt. In this case, 20 is a literal. It's a value that is literally typed into the code. This next example, you're not doing a literal. I could type in 20 at the command prompt if I wanted, but it's not a literal. It's a variable. It could change every time you run. A literal stays the same every time the program runs, no matter what. So, and things like this right here, constants are normally literals, right? That value of 3.14159 is not going to change. It's literally typed in, and it's not going to change no matter how many times you run the program. So that's what we would call a literal. Think of something being literally typed into the program code. And you can do literals for any type of variable, integer. This thing is talking about accessing literal integer values with different types. So this comes to the concept of something called promotion and demotion. And they'll probably cover it again, but essentially what is a string literal? It can be a literal. We haven't gotten to strings yet, but yes, any data type can be a literal. So this is going to bring us to the concept of promotion and demotion. The concept of promotion means that if you take a value in a variable, like an int, and you store it in another variable declared as a long, that's a promotion, because long can handle more data than the int. So it can handle the int's data and then some. So we call that a promotion. However, if you went from int to short, that's called a demotion, because now you're going from a type that can store more data to one that can store less, and that's a demotion. Okay, so that's sort of the concept, what they're saying there, and we may get into promotions and demotions later on, but basically that's what this means here. Floating point literals are just floating point literals. With Java, you actually can give it a help if you want. For example, radius is a double. So here I said radius is equal to 20. And even though radius is a double, because I'm only storing 20 in it, which is an integer, Java may, in an effort of efficiency, treat it like an integer. And that can cause weird calculations to happen, so you have to be careful. So if you want to force Java, because Java has an optimizer, to treat it as a float or floating point or a double number, no matter what, you have to do this little trick. And that forces it to always be treated as a double. So even though you declared it as a double, if you initially use it with an integer, Java in its efficiency will treat it as an integer from there forth, and you may get some weird calculations. Most languages, well, not all languages, but so that's kind of what this thing is saying, is that you may want to force it to be seen as a double or a float by doing that. There's also scientific notation, which is an E. We don't use scientific notation very much for your typical business or web applications. That would be more scientific applications in nature. And again, here's a long arithmetic application expression. I'm sure you probably pulled your hair out over something like this on a high school algebra final exam or something like that. If we were to translate it to a program, it would translate like this, essentially. Parentheses have the same role in computer math and computer programs in general as they do in math. They force the order of operation. And again, this whole thing goes through the whole operation, saying the innermost parentheses executes first, which we know from math that that's the case. Parentheses force order of operations, right? And you always go from the innermost parentheses and you work your way out. This is just saying that programming languages do exactly the same thing. They follow the same exact math rules that math follows. And again, this could be translated to from Celsius, from Fahrenheit to Celsius. How would you do that? Well, here's your formula. And note that it's putting a 5.0 in here to make sure that Celsius actually stores that value. Alright, so we're going to get to time. This is a complicated thing because time has seconds and minutes, has seconds and minutes and hours, and it's different from different time zones. And then doing math with time is difficult. And depending upon what operating system you're in, Unix operating systems generally use January 1st, 1970 midnight Greenwich Mean Time as their starting point, because that's when 1970 was the year that Unix operating system was formally introduced. You can use that method. So again, like I said, it adds essentially a second, or it might even be milliseconds, to a base time to calculate the current time. There's shortcut assignment operators, and we don't have to get into this just yet, because in longhand or algebra, you would write something like, I equals I plus 8. If I started out as 4, I would now be 12. Most programming languages give you a shortcut way of doing that with these operators. Plus equal operator, essentially what it says is that if you say something like I plus equal, it translates it to this. So it says you don't have to repeat the I again. If you say plus equal, I know you're using the same variable over again. So you don't have to write it out. It's a shortcut. I would just say for people that are starting out, don't worry about it so much, because you just do it longhand if that's more comfortable. Eventually you'll get more comfortable and you want to take the shortcuts. But when you're first learning, it doesn't really make sense to take shortcuts unless you feel really comfortable with it. Increment and decrement operators, plus plus some variable, variable plus plus, minus minus some variable, variable minus minus. This is another shortcut. So when we say that we want to have a variable and we want that variable to be a counter or an increment, means a counter is 1, 2, 3, 4, 5, 6, 7, right? And you might do that with a variable. The longhand way of writing that out might be something like int counter, and I will initialize it to 0. And then down here I can say counter is equal to counter plus 1, right? That would be a typical way, so that every time you do something, you add 1 to the counter, so you know how many times you've done it. Well, what these are saying is there's a shortcut way of doing it, and it essentially looks like this. Or putting the plus signs before it. Again, it's a sophisticated shortcut, and there's also a difference between whether you do it before or after. So, since you're beginners, I don't even like to really show these shortcuts to beginners. I almost prefer they wouldn't, because they're not necessary to program. You can write it the long way. And, it's probably, when you're starting out, the safe thing to do is to write it out the long way. But the shortcuts are there, and eventually you may want to use them. And there's also a difference between post and pre-increment, meaning whether the plus plus sign is before or after. And the minus is the same thing, it's just on the opposite. It subtracts 1 instead of adds 1. So these always will add exactly 1. So if you say here int I equals 10, then int I equals 10 times I, it's weird because what happens is that the increment, if the double plus sign is after the I, it uses the value in I and multiplies it by 10 first and then increments it by 1. And that's kind of confusing, right? So I would say, forget about it. Don't do it. If you've got this right here, times I, and then I equals I plus 1. Okay, you're better off doing it that way. Longhand. It's going to be easier.